Hi Math 54. This is the video for Investigation 11, which is located on page 513 and is scheduled for Thursday, April 9th. When we look at these shapes on my page, we've talked about how these shapes take up area, but they don't have height coming off the page. They're just flat and take up area. What we're going to work with today is called volume. Volume, when we look at these geometric solids that we've dealt with on previous lessons, not only do they take up a little space on the page, but they have height that comes off the page, okay? So they have a height also. So they take up space, and determining the amount of space that the shape takes up or occupies is called volume. So in your book, it starts out with volume on, if we come down to problem number 1, it's a volume problem. And the way it starts to explain volume is to think of it as little bitty cubes making up the bigger shape. So when we look at number 1, it asks us, in order to determine the volume, count the cubes to find the volume of each rectangular solid below. And notice the units. So if we look at number 1 and we want to count these cubes, we have to look and say, okay, there's 1, 2, 3, 4 cubes on this front piece. And then notice that there's 2 layers of those front cubes. So there would be a total of 8 cubes making up this solid. So for number 1, all we did was count the cubes, and we came up with 8, and then we have to use our units. So our units, when we're dealing with volume, it is cubic units, whereas when we dealt with area, it was square, like square centimeters, square inches, square feet. Now, when we're dealing with volume, we are dealing with cubic. So it's cubic feet. Or you can also abbreviate that. There's a couple ways. There's 8 feet cubed, or you could do 8 CUFT. All 3 of these mean the same thing. Those are 3 different ways to abbreviate it. In a minute, I'll explain that one to you, of why there's an exponent. Well, it'll explain all 3, but I'll explain why there's an exponent of 3. But either of those 3 would be a proper way to write 8 cubic feet. And all we did here was count the cubes. Nothing fancy. Okay? So number 2. Looking at number 2 in the book, it wants us to do the same thing. So we're going to count the cubes. So we know that we have 3 times 4, we have 12 cubes. I know that because I have, 1, 2, 3 down, and 1, 2, 3, 4 across. So I did 3 times 4 is 12 cubes on this front layer. Then I look behind and know that there are at least 2 layers. So 12 cubes times 2 layers would be 24. So I know that my answer is 24 cubic, and then my units are centimeters. Okay? Or 24 cm to the third, or cm cubed. It's said different ways, but let's go with cubed in this regard. 24 centimeters cubed. So that's an exponent. If you remember, we've written and learned about exponents before. So 24 cubic centimeters. Okay, I'm turning the page. Now I'm starting page 514. So be sure you've turned the page with me. And let's look at, we're going to do the same thing for number 3 and number 4. Okay? So number 3 says, basically we're counting the cubes. We're following the same instructions, okay? So I have 3 rows of 3. So 3 times 3, I have 9 in my layer. And then I have to look, how many layers do I have? I have 1, 2, 3 layers. So 9 times 3 layers, 9 times 3, would be 27 cubic inches. 27 cubic inches. That would be the other way to write that. Okay? All right, number 4. Same concept. I have 1, 2, 3, 4 in a row, and I have 1, 2, 3, 4 rows. So 4 rows with 4 in each gives me a total for this face here of 16 in this front layer. And then I have to look over here and say, how many layers of 16 do I have? And I have 3 layers of 16. So 16 times 3, and I can work that one out if that would help. 16 times 3, 6 times 3 is 18. Carry my 1 forward. 3 times 1 is 3 plus 1 is 48. Cubic, because I'm doing with volume, so I know it's cubic, and then I have to go determine what is it? M. M for meters. Cubic meters. Okay? So that would be my answer for number 4. Now, our instructions are going to change a little bit, but first it's going to give us some information. When we count, so basically what we were doing on 1, 2, 3, and 4 is we were counting these cubes, and we were adding them up by doing that and then multiplying by the number of layers. So what we were doing, if we, like for example, when we get down to number 6, you'll see they just give us the dimensions. They don't give us all these little cubes to count. When you are doing volume, you end up multiplying 3 things together. You multiply the length of the shape times the width of it times the height. Okay? So length times the width times height. 3 different units. Now, going back here, I told you that we have this exponent of 3 here. That is one of the ways to write your volume. So if your length is in centimeters, and your width is in centimeters, and your height is in centimeters, remember, an exponent gives you a base number, or a base unit, centimeters, and then that little exponent up top tells you how many times to multiply it by itself. So here we multiplied centimeters once, times centimeters, times centimeters. So we multiplied centimeters times centimeters 3 times. So that's why that exponent becomes cubed. Now, if that's confusing to you, just write cubic centimeters, and that's okay. All right? I just wanted you to understand why you'll see it written this way also. Okay? So anyway, back to volume. When we find the volume of an object, what we did on 1 through 4 was we counted the little cubes. That's what it looked like we were doing. But in reality, what we were doing was taking the length. Let's go back. The length, let's look up at number 4 with me. We took the length, which if I'm going to work that out, was 4 meters. I'm going to scratch this because that's not relevant to number 4. Times the width, which was 3 meters, times the height, which is 4 meters. Now, I got those units from this picture. I know it's length times width times height. The length is right here. The width, going how deep back it is, or how, and when I said it the first time, I said how many layers, and the height right here, 4 high. So we use that to multiply together. And when we did that, 4 times 3 is 12 times 4, which equals 48 cubic meters, or 48 meters cubed. Okay? So now on the next set of problems, instead of going through and counting the squares, we're going to do it the mathematical way, the multiplying way. How about that? So we have the answers for 1 through 4. Now we're going to work on number 5. Now another thing, a piece of info it gives us that's important is this piece of info right here. It doesn't look like much, but it is important to look at, because what this tells us is that 1 yard is equal to 3 feet. You see that? If this distance right here is 1 yard, over here it tells us it's 1 yard. This distance over here tells us it's 1, 2, 3 feet. So if we need to know on some of the problems that 3 feet equals 1 yard. If your parents let you write in the book, you can write out that, or you can just look at this picture, however you'd like. So let's look at number 5. The length, width, and height of this cube, talking about this cube right here, are each 1 yard. So let's look it over. We have 1 yard, 1 yard, 1 yard. Okay? So the volume of the cube is 1 cubic yard. The way it determined that for number 5, just to show you, is it took length. I'm gonna use an L for length, a W for width, and a H for height. Length times width times height. Okay? And on number 5, it took 1 yard times 1 yard times 1 yard. Okay, and I got that 1, 1, 1. And that equals 1 cubic yard, because 1 times 1 times 1 equals 1, and yard times yard times yard equals a cubic yard. Okay, so I'm just showing you how they got that information. So the volume of the cube is 1 cubic yard. What is the volume of the cube in cubic feet? Okay, so now it wants us to, and I'm going to continue number 5 over here. 5, and write down my length times my width times my height. Okay, I know I'm going to use that. I have to go to my cube, and I see they already wrote it in feet for me, because we know 3 feet is equal to 1 yard. So my length is 3 feet, so I can write that down on my paper. 3 feet. My width right here, how deep and wide, how wide or how deep it is, some people call it depth, 3 feet. And my height, how tall is it? It's 3 feet tall. Okay, so now I can just multiply. I know that 3 times 3 is 9, times 3 is 27 cubic feet. That's my answer for 5. Okay. Moving on to number 6. Number 6. It says 1 foot equals 12 inches. 1 square foot equals 144 square inches. All they did there was take, if it's a square foot, that means they took 12 times 12 to get a square foot. And 12 times 12, if you don't know, is 144. The volume of this figure is 1 cubic foot. That means it's 1 foot long times 1 foot wide times 1 foot high. What is the volume in cubic inches? So it wants us to take the inches measurement, which is 12 times 12 times 12. So on number 6, my volume formula is length times width times height. I know that it wants my volume in cubic inches, so I know I'm using the inches. and it already gives it to me, so 12 inches long, so I'm going to fill that in. 12 inches times, how wide is it? It's 12 inches wide. And how high? It's 12 inches tall. 12 inches, okay? So I have 12 times 12 times 12, okay? So I know that 12 times 12 is 144. So that's this, and then I have one more 12 to multiply it by, okay? So I'm gonna go ahead and work that out. So we can see 2 times 4 is 8, and 2 times 4 is 8, and then 2 times 1 is 2. Remember to put my placeholder 0. Now I cover up my 2, and I start with my 1. Sticky note. Okay, there we go. 1 times 4 is 4. 1 times 4 is 4. 1 times 1 is 1. Now my step is to add. Okay, 8 plus 0 is 8. 8 plus 4 is 12. Carry forward my 1. 1 plus 2 is 3. Plus 4 is 7. And 1 plus 0 is 1. So my answer is 1,728. But that just is my number. Now I have to know what my units are. I multiplied inches times inches times inches. So I multiplied inches 3 times. So it is cubic inches. That is my answer to number 6. Okay? Number 7. 1 meter equals 100 centimeters. 1 square meter equals 10,000 square centimeters. So that just means they took 100 centimeters times 100 centimeters and got 10,000 square centimeters. They did the math for you. A shape with a volume of 1 cubic meter has a volume of how many cubic centimeters? So these problems are giving you a lot of info, okay? Don't let them scare you. All right, let's see. Number 7, I know I'm doing volume. So I'm gonna start with what I know. Always when I'm doing volume, it's gonna be length times width times height. I just have to plug those numbers in where they go. And they give them to me in this problem. So number 7. So here they say this shape is 1 meter tall, 1 meter deep, and 1 meter long. So 1 meter long, 1 meter wide, 1 meter high. Excuse me, I didn't want to confuse you by using the wrong terms. So that gives you a lot of info. What is the question? So a volume of how many cubic centimeters? So it wants to know how many centimeters is the volume, cubic centimeters, is the volume for this shape. So we're not going to pay attention to those meter measurements right now. We're going to pay attention to centimeters because that's what our question's asking. So let's look for our length. Our length is 100 centimeters. So I'm going to write that as my length times my width is also 100 centimeters. And my height is also 100 centimeters. Okay? So now I just have to work that out. So when I'm multiplying numbers that are, when I'm multiplying 10, 100, 1,000, 10,000, any number that starts with 1 and has a bunch of zeros behind it, I can go through and I can multiply these first digits. 1 times 1 times 1 equals 1. Then I can go through and count my zeros. I have 2, 4, 6 zeros. So my answer has to have 6 zeros. 1, 2, 3, 4, 5, 6. And we know when we do commas in our numbers, we start from the right and we count to the left and do a comma every third number. So 1, 2, 3, comma. 1, 2, 3, comma. So now that takes care of my number, but I have not taken care of my units. I multiplied centimeters times centimeters times centimeters, so it will be cubic centimeters, or cubic centimeters. So my answer is 1 million cubic centimeters for number 7, because it just wanted me to find the volume in centimeters. It gave me a lot of info I didn't need. In fact, all these problems gave you one piece of info you didn't need to get to the rest. Okay, so let's look at, now I've gone to page 515. Items that we see on store shelves are usually shipped to stores and trucks. The amount of merchandise a truck can carry depends, I'm just reading to you from right here, upon the capacity of the truck's trailer and the weight of the items being shipped. Suppose the storage area of a delivery truck is shaped like a box that is 5 feet wide, 6 feet high, and 20 feet long on the inside. So it's talking about the trailer part of this truck, kind of like when you see the 18-wheelers on the road, they have a truck part and they have a trailer part. So those dimensions just deal with this trailer part right here. That's all we're dealing with. So it's saying number 8, when we look at it, it's asking, what is the volume, the amount of space that it takes up, or the amount of things you can put in it, in this case for a trailer. What is the capacity? That's the word for capacity. How much can this hold of this storage area of the truck in cubic feet? So let's look. It gives us the dimensions in feet, so that's good. So number 8, we'll start off with writing down, again, we're dealing with volume. So our formula that we're gonna work with is length times width times height. Now we have to go to our trailer and find where those pieces are. How long is the trailer on our truck? And the words tell us, and the picture tells us too. The words tell us 20 feet long. The picture right here tells us 20 feet long. So I'm gonna write 20 feet times, now I need to know my width. The words tell me it's 5 feet high, and the picture, 5 feet wide, 5 feet wide, and the picture tells me it's 5 feet wide. So I'm gonna write 5 feet for my width and height. The words tell me it is 6 feet high, and the picture tells me it is 6 feet high. Okay, now it's just like all the other problems we've worked. We're looking for the volume, or in this case for the truck bed, the capacity of how many feet can fit in that truck bed, how many cubic feet. So when we look at this, we have 20, and I'm gonna go ahead and I'm gonna choose to multiply 5 times 6 together first, because that will give me 20 times 30. Then I know, because both of these are multiples of 10, I can take 2 times 3, and that'll equal 6, and then I can add in, I have 1, 2 zeros, so my answer needs 1, 2 zeros. Okay? So I know that I have 600 is the answer to my number, and then in feet I multiplied feet times feet times feet, so I multiplied feet 3 times, so it is cubic feet, either way. You can write it either way. I'm writing it both so that I don't confuse anyone. Okay? So you just have to do the multiplication on that one. Okay. Let's keep going. Let's see what's next. Now suppose the truck is to be loaded with boxes with the dimensions shown at right. The first boxes are stacked against the back wall, which is 5 feet wide and 6 feet high. How many of these boxes can be stacked against the back wall? Draw a diagram, okay? Let me get another piece of paper. All right, so number 9. If I can get it. The truck in there and my sheet of paper. There we go. Okay, number 9. So we have these boxes and it's saying dimensions are shown. So we have the wall of our truck. Let me draw that first. The wall of my truck here. And I know the wall of my truck is, it tells me right here, the first boxes are stacked against the back wall. So this is if I got in the truck, you know how they have those big doors on back and you open up those big doors and look all the way down to the front of the truck to that back wall, and you had to go walk all that way and put boxes against that back wall. That's what this is representative of. So I know it is 5 feet wide. This is wide, and it is 6 feet high. So I know it's 6 feet high. Okay? So I know that's what my diagram looks like. Now I have to look at it and say, okay, here's my little box that I was given. I have to find out how many of these boxes can go in this space. My box though, what do I know about my box? I know my box is 2.5 feet long, and I know my box is 3 feet high. Okay, so let's see. If I have, let me get another color. If I have a box that is, so it's 2.5 here, and it's 3 here, okay? Let's look at the length first. I don't know if you can see that really well. 2.5 feet, and I have 5 feet of space, okay? If I have to put 2.5 feet in 5 feet of space, how many boxes across could I fit? Well, I could fit another one here that would be 2.5, okay? So 2.5 plus 2.5 would give me 5 feet. So I have all the space I can fit going across right now, going lengthwise. Okay, now I have to look at my height. So if I have another box here, and this box is 3, if I fit it across, I've got to fit it up too. And I know I've got 3 feet of that taken up. I've gotten my whole length taken up here, but now I have this whole height. I have to go up. I'm stacking it on top of each other. Like, let me see if I can use these as an example. So I have right now on my, if I have a back wall, I have 2 boxes stacked next to each other, and that takes up all 5 feet across, okay? But now I know I've got 6 feet to come up, okay? And I know right now I'm 3 feet up, so I only have 3 feet left. So I can only fit 2 more boxes because it tells me my box is 2.5 feet wide. So 2.5 plus 2.5 we decided would be 5 foot, which tells me the whole width of the truck is 5 foot on that wall. So I've covered it completely from wall to wall on my little truck. And then it's 6 feet high. So each box is 3 foot. So this box would be 3 foot plus this box would be 3 foot. That covers 6 feet high. So how many boxes can I fit? Going back to my diagram, I can fit 4 because these boxes will be 3 feet high each. 3 feet plus 3 feet is 6 feet tall. And 2.5 plus 2.5 is 5 feet wide. okay? So my answer to 9 is 4 boxes. And that's your diagram, or similar. Yours will be much neater than mine. But 4 boxes is your answer to how many it can fit. Okay? So number 10. Number 10. If these same size boxes continue to be stacked in the truck in the same manner, then how many boxes will fit in the truck? Okay, so this is going back to, let's see if I can use my little diagram of boxes here. So I know I have 4 on the back wall, okay? So this is the back wall of the truck and the back wall of the trailer of the truck, and that trailer comes out all this way over here to where the double doors are that the guy closes it in. So it's asking how many, let's see, how many boxes will fit in the truck. So it's saying if I can fit 4 on that back wall, and then I can fit 4 more, and 4 more, and 4 more, and keep going until I fill my whole truck, how many boxes can I do? In order to do that, we have to know how long the truck is and how long each box is. Okay, so you would keep doing stacks of 4 boxes until you got to the full length of the truck. Okay, so let's look at what the full length of that truck is. Let's see, on number 10, or somewhere it tells us the full length of the truck up here, going way back up. Oops, I'm not on the screen with that. Hang on. Okay, going way back up to there. It tells us the full length of the truck is 20 feet. Okay, and so we know that these boxes are 2 feet wide. 2 feet wide. So each box is 2 feet wide going across the truck. So on that back wall, 4 boxes comes off that back wall 2 feet. So if we have a 20-foot truck, okay, try to draw this, make more sense that way. And on this, this is the back wall right here, and I have already 4 boxes stacked on it. I can only see this 2, but there's 2 more on the other side. Okay, and I know my entire truck from here to here is 20 feet. And I know my box is 2 feet wide. First thing I need to do is determine how many stacks of boxes can I make. So if it's 2 feet wide and my whole truck, sorry, I'm not totally on the video. There we go. My whole truck is 20 feet, and my stack of 4 boxes back here on this back wall, I'm looking at the side of the truck now, like this picture of the truck. And so this back wall here is 2 feet. I've got to determine how many 2 feet stacks of 4 boxes can I fit. And 20 divided by 2 is 10 stacks. So I know I can fit 10 stacks of boxes. And I know that each stack from this problem here has 4 boxes in each stack. So 10 stacks of boxes times 4 boxes in a stack gives us the answer of how many can fit across this 20-foot truck. 40 boxes can fit across the truck. Okay? So that is the end of the part of this investigation that we can really do together. If we were together in a classroom, we would measure our classroom and continue on in class if we had the time. But this part is really good. We do typically do this in class, where we measure out our classroom and determine the volume of our room. So if If you want to do your bedroom or something like that, maybe you could have your parents help you and determine the volume of your bedroom with a yardstick or a tape measure, and just it tells you to round them to the nearest yard or the nearest foot so that you can work with them on page 515. And it continues on to page 516. And so it just is basically asking you to calculate the volume of your room, okay? And do it in yards and do it in feet. So kind of the same thing we've done, and then it has a diagram. Your parents can decide how much of that they would like to do with you. I wish we were together so we could do it together in our classroom, because our classroom, being a perfect little square that it is, or little rectangle, excuse me, that it is, would be a great room for this. So that is the end of what we can do together on a video on Investigation 11. And so that's the end of week 10. That's the end of week 10. So as a reminder, your week 10 homework will be due on Monday, April 13th. It includes lesson 107, 108, 109, 110, and investigation 11, and test 21. I hope you're doing well. I miss you all.